This is a diagram of the basic design for the Windkessel modulated ventilator. It has a rigid Windkessel chamber with a volume of about 1.4 gallon. It has 4 electronically controlled solenoid valves. It has 2 pressure sensors, 1 passive safety valve to prevent overpressure to the patient, and a manual clamp valve to regulate the rate of flow in this channel. The operation principle of this design is based on the ideal gas law, which says the product of pressure and volume of some amount of air before it expands is the same as the product of the pressure and the volume after it expands, and that's what these subscripts denote is before and after. So in this design, we take in compressed air from the airline and store it in this Windkessel here. So the volume of the Windkessel has a volume VB, and it has a pressure of PB that's measured by this pressure transducer. Now when we want to push this air to our patient, then what happens is this valve opens and this air that's in here expands to fill the patient's lungs. So now this whole thing is our VA. This is the volume after expansion. If you think about what this VA is, it really is just this volume of the Windkessel, VB, plus the volume that we deliver to the patient, which is our tidal volume. So VA really expands to VB and V tidal. The pressure after expansion is measured by this pressure transducer, and that is essentially our inspiratory pressure. There are a few details that I'm not discussing, but the main idea is that we know the volume of our Windkessel, and for a given tidal volume that we want to deliver to the patient and a given inspiration pressure, we can decide how much pressure to accumulate in the Windkessel when we fill it for each cycle. We can set the desired initial pressure inside the Windkessel by modulating the timing of this valve, the inlet valve, and if needed, using a release valve. We can set the inspiratory and expiratory ratio by adjusting the clamp valve here. The more open the valve, the faster the flow through this channel, and the shorter the inspiration period is, and vice versa. The ventilation pressure is continuously monitored by this pressure sensor here. During the expiration period, this valve is closed and this valve is open, and we monitor the pressure in here to close this valve at the right time to maintain a desired PEEP. At the same time that the patient is exhaling, the Windkessel is filling to set the correct initial pressure for the next cycle. This design has no moving parts, which makes it more reliable and robust compared to many other low-cost ventilator designs involving mechanically squeezing a bag. This is the entire parts list. The construction is very simple. Most of the complexity in this design is in the control algorithm, which once it is developed can be directly uploaded into the microcontroller. Since the electrical power requirement of the design is very low, if needed, the device will be able to operate on battery for many hours.